All right, today we're doing 10-5 special cases. We're actually only going to spend one day on this, but it says day one. Right now, if you haven't already done so, you need to list the first 16 perfect square numbers on your note page. Okay, perfect squares. Ever know what a perfect square is? Like if you're finding the area of a square, you multiply the two side lengths together. So a square that has a side length of 1 would be 1 times 1, which would be? Not a trick question. Yeah, it's 1 squared, or 1. Okay, so that's the first perfect square. The second perfect square is 2 times 2, or 2 squared, which is 4, and then so on. So you need to list the first 16 perfect squares, and then also answer those two questions right there. I'll give you guys a minute or two to do that. All right, here we go. We're going to start with Bobby. The first perfect square, Bobby, was?
1.
1. Toki, second one.
4.
4. Ryan?
9.
Keegan?
16.
Parker?
25.
Gents?
36.
Cole? Patrick?
64.
Kinchin? 1 times 1, 2 times 2, 3, 4, 5, 6, 7, 8, 9 times 9? 81. Good. Burley? 100. All right. Audrey?
121.
Good. Annalise?
144.
144. Jennifer? 169. 13 times 13. Tough one. 169. TT?
196.
Good. 14 times 14 is just flipping those back two numbers. 169 becomes 196. We do 14. Ayla? Is that pretty? It's 2. Anyone want to help? Yeah? 225. Yeah. 225. And 16 times 16? Chelsea? All right, someone help out there. Yeah? 256. All right, so that's our first 16. You should really memorize the first 16. Okay, if you can get to the first 20, that's even better. Okay, but then we go over here and I say, what is 20 times 20, or 20 squared? Well, that's just 2 squared, which is 4, and 2 zeros, because you're doing 20 times 20, 400. So what's 30 times 30? 900. Okay, 40 times 40, tell your neighbor. 1,600. 50 times 50? 2,500. Okay, so perfect squares are going to help you out today. All right, we're going to do some factoring. And what I'd like you to do is start out with problem number 1 here. All right, number 1. Let me cover some of these other guys up here. Let's start by factoring that. Just like you have all other problems. Okay, identify A, B, C. Or multiply A by C. Use the whole process that we went through. Okay, give yourself a minute to work on that one. Go ahead and share your neighbor or your answer with your neighbor. All right, what is A? Lily, what'd you get for A? 1. Mackenzie, B? How about C, Mackenzie? You don't know? Remember the form ax squared plus bx plus c. So Mackenzie, what's being added to our x? B is not -4. C is -4 though. So Annalise, what's B? B is 0. So you could rewrite this one if you wanted to. You could rewrite it in this form. X squared plus 0x minus 4. Now we usually don't, but you could. Okay, and so really the question is, if you go through this and you say, well, A times C, well, since A is 1, Bobby, put that away. A times C is -4. right? So we're finding two things to multiply to make negative 4 and add to. We're trying to add to what? 0. The two things that multiply to make negative 4 and add to 0. If you're adding things to get 0, those two things, tell your neighbor what those two things have to be. Okay, so Jake, if I have 1 and I want to get to 0, what do I have to add to it? So if you're at 1, and you want to get to 0, what would you have to add to? 1. Negative 1. TT, if I'm at 4 and I want to get to 0, what do I add to it? Good. Chelsea, if I'm at 7 and I want to get to 0, what do I have to add to it? Okay, so the two numbers have to be similar, right? One has to be positive, one has to be negative. Are there two numbers that multiply to make negative 4 and add to 0? Annalise? Yeah. 2 times 2, and one of those 2's has to be negative. Okay, now how many got that? Okay, so we're setting up our parentheses. If we have a negative c, what do we have in our parentheses? What are the signs? Caden? Positive and negative. Patrick, what goes here? X. Cole, what goes here? Bobby, what goes here? 2. Marie, what goes here? What's that? I didn't hear. 2. All right, good. X plus 2, x minus 2. Got it? Okay. Let's try this one. Number 14. Divide by A, you mean?
Oh, yeah.
Yeah, if we divide by A, what's A?
Well, I mean, it would be the same thing.
It'd be the same thing. So yeah, we technically do, but it would just be wasting our time. It would be like me saying, hey Jaden, tie your shoe. No, untie your shoe. Okay? Be like, just waste. So we don't do it. But on this one, is it going to be the same? No. Start by identifying A, B, C. And if it helps you to rewrite it, rewrite it. Okie, what'd you get for A? 9. JC, B? 0. Chelsea, C? Negative 25. All right. So we get 9x squared plus 0x minus 25. So in this case, 9 times 25 is what? Caden? Good. Negative 225. That's A times C. And what do we know about that number negative 225, or at least 225? Yeah? Good. 15 times 15. How many of you remembered that from our warm-up? Positive 15 times negative 15. Now we could list all the other factors, but we're trying to make 0, so we know that the numbers have to be the same. So as I make my parentheses, it's once again plus minus. Here we have x, here we have x. We got 15, and we got 15. Jaden, what do we have to do this time?
You have to divide the 9.
Yeah, we got to divide by 9. Okay, now when we reduce 15 nines, what goes into both 15 and 9? Annalise? 3. So we reduce here. 3 goes into 15. 5. And into 9? 3. Okay, so 5 and 3. And so our front term becomes 3x. Back term is 5. And 3x minus 5. How many got 3x plus 5, 3x minus 5? Okay. How many figured out where they made their mistake? Anyone forget to divide by A? A couple of us. How many didn't reduce? Okay. So easy things to fix. I want you to compare this answer now to the original problem, and this answer to its original problem. There's a quicker way to get from here to here, and a quicker way to get from here to here. How many like shortcuts? Like if your PE teacher, you like doing the Colt run today, and they go, hey, you can do the whole run, or you can take the shortcut. Here's the shortcut. And they give you a little path you can go through. You like maybe skip part of the run. Now some people wouldn't like that because they love the running. Like I'm pretty sure my son Eli would just do the whole run. However, there would be some people that do the shortcut. We like shortcuts in math. Okay, there's a shortcut to get from here to here and here to here. Talk with your neighbor, see if you can figure it out. Hey, Hey, remember the beginning of our lesson today? We talked about, remember what we talked about, what you listed on your paper. You should be able to somehow try to relate the 4 and the 2s, the 9s and the 3s, the 25 and the 5s. There's your hint. Okay? Some of you already have it. Not sure, but I think I have the shortcut. Okay. Anyone want to give me the shortcut? Or actually, test your shortcut on this problem. Let's see if you test it out. Let's say you have, whoops, didn't mean to put a random parenthesis there. All right. Let's say you have 4x squared minus 64. There you go. See if your shortcut works. Okay, share it with your neighbors. See where you got. Okay, how many made it that far? You got parentheses. Well done. What goes here? Plus, and here? Minus. How do you know it's plus minus? Yeah? Yeah, because C is negative, right? Okay, how many made it that far? All right. How many got the X's in? Very good. Square root of 4 is 2. How many got the 2's? Square root of 64 is 8. How many got the 8's? That's the shortcut. Isn't that cool? How many had the shortcut right? Me. Yeah. Okay, this is called the difference. E-N. Unbelievable. All right, if you could spell difference. Difference. I almost spelled it wrong again. Difference of 2 perfect what? Squares. Okay? Difference of 2 perfect squares. The word difference means subtraction. You have to be subtracting in order to use this pattern. Addition, it doesn't work on. If that says add, it doesn't work. Okay? So difference. 2 perfect squares, well, because there's 1 perfect square and a second perfect square. Yeah?
So if it's addition, is there a different shortcut for that as well, or do you have to go through?
There's not, if it said like 4x squared plus 64,
Yeah.
the only thing you could do on that one is take out a 4. That's it. Okay? And technically we could have done that, but we didn't up there. Okay. Here you could just
solve it the other way.
you solve it, but there's no C term, so there's no possible way for anything to cancel, right? So like if I'd still have to use 8 and 8 to get, or I find 2 things that multiply to make 64, nothing would end up working on this one. So you try it, but it wouldn't work out. Yeah, you'd solve it using the other method. If it's subtraction, you can use this process, okay? All right, so let's see. Let's say this is one on your assignment today. Actually, let's do the first 2 on your assignment. Number 1 and 2. X squared minus 9 and 4m squared minus 1. All right? Go ahead and give those 2 go on your paper there in your notes while I hand out your assignment. Okay, how many of you are done with both of them? All right, let's check the first one. First one is, what goes in here? Plus and minus. And we know that because this is a subtraction, right? Okay. And what'd you say it was, Jake? And then? How many got it? Very good. All right. Toki, what'd you get on this one?
2m plus 1 and 2m minus 1.
Very good. That's it, man. It's that simple. Here, remind your neighbor really quick what has to be true in order to use this pattern. Okay, there's 3 things that you must see in order to use this pattern.
It can be two whole numbers, and it has to be a negative.
Okay, Lily, what's one thing?
It has to be with subtraction. It has to have a difference.
Good. Must have a subtraction. What's another thing? Annalise? Have to be two perfect squares. Perfect and perfect. Okay? All right. Very good. That's why I like Richard Sherman's number. It's a perfect number, dude. Yeah. What? Unbelievable. I'm going to pretend like I didn't even notice. Oh, man. All right. Any questions? All right, you guys have 5 minutes, actually 6 minutes to go through this page and do all the difference of two perfect squares that you see. Any questions? All right, let's see, real quick. Make sure you got them all. Any other perfect squares in row 1? Row 2? What number? 6. Row 3? 7? 8? Row 4? 11? Yes? No? Could we make it a perfect square? I mean, it has two terms.
But
Divide the whole thing by 2. Yeah, let's do that. Let's pull out a 2. That gives us a squared minus 9. Now is it perfect? Okay, finish it up now. Nice job. Who said that? Divide by 2. Keegan? You the man. Jeez. Holy moly. Anything by Keegan. All right. So anyone want to tell me what they got? Bless you. Anyone get a plus 3, a minus 3?
Yeah.
All right. And just no one want to tell me that. What goes on the outside? The 2. So if there are 2 terms, you still want to see, hey, maybe there's something we could divide by. Factor that out and then write it down. So that might change your answer, like on this row. How many said 15 was perfect? Very true. How many said 13 was? Is it now? Can you make it perfect?
yeah.
Yeah, try it. Try to make 13 perfect. All right, so what comes out of it? Jade? 30. Okay. And then what do we have? So we get, is this perfect? Yeah. So we get n plus 1, n minus 1, and we just put the 3 on the outside. All right. Good. I'm going to give you guys, yeah, Lily?
On 23,
Uh-huh.
can you still do the same, like, shortcut, or
Right here?
is it 2 cubed instead of 2 squared?
Yeah, this isn't perfect, is it?
Yeah.
Because it got the g. But is there anything you can take out?
Oh, gee. Okay.
Oh, g. Yeah, man. You take a g. That might make it perfect in here then, right? You pull a g out, you're left with what and what. Okay? So I'm going to give you guys another 2 minutes to finish as many of those on the page. See if there's any others you can make perfect. All right. So, any of these that you aren't sure about? Like if we finish this one up, this should have been g squared minus 25. You get g times g plus 25, g minus 25. Gee whiz, man. If you ever get to one where you can't take care of it, then you just say, yeah, it's no solution, or it's a prime. It's called prime. Okay. All right. So taking a broad look at this page, which problems, how many terms did all the problems have that were difference of 2 squares? Bless you. Good, yeah, everyone on your fingers. How many terms? It's not 5, but that's what I have. How many terms in here? 2. How many terms? 2. The ones that you haven't completed should all have how many terms right now? 3. Okay, so that's another way to look at difference of two perfect squares. You're like, hey, it has 2 terms. Dude, that might be a difference of 2 perfect squares. Okay, maybe you have to pull something out first, like on 18. Pull out that 3 first, and then try it. Okay, but that's difference of 2 perfect squares. Difference of 2 perfect squares if you take something out first on some of them. All those 2-termers on here should be able to get down to difference of 2 perfect squares. All the 3-termers, those are tougher. Okay, they're normal factoring. I want you to look at the C term on number 3. What do you notice about it? How about 4? How about 5? How about 9? How about 12? How about 10? 14. What do you notice about all those C terms? What do they have in common? Marie? They're all positive. Okay. Anything else? Jade? They're all perfect squares. Yeah. So let's take one of these. Let's try, say like number 3 here. Okay. A squared plus 2a plus 1. Okay, this is actually, let's use a tougher one. Let's use number 4. Okay. All right. You'll notice this is a perfect square. And this is a perfect square as well. Your A term and your C term are perfect. Now we're going to factor this normal way. I want you to list A, B, C. Okay, you get 10 seconds. Write them down. A, B, C. Okay, see if you got it. Most of you are pretty good about that. All right, A times C, 4 times 9 is 36. Okay, it's positive. 2 things to multiply to make 36 and add to 12. 6 and 6 and 6. Dude, 6 and 6. Okay, both going to be positive 6s, right? You guys getting pretty fast at that? Okay. Well, notice these are the same number again. All right. Well, let's just go to its neighbor real quick. We're not done with this problem yet. Okay. We're going to put an asterisk here. We're not quite done. All right. Let's go to number 5. ABC. Write it down. That's a lot of toys. Okay, this is 1, negative 22, positive 121. Okay, we're trying to make what number? Positive 1, oops, thank you. Trying to make positive 121. 2 things to multiply to make 121 add to the negative 22 are? Yeah? Negative 11 and negative 11. All right. What are our signs? Yeah? Negative, negative, 11, 11. Okay, tell your neighbors similarities about these 2 problems. We're trying to show you another shortcut. You liked the last one and made your assignment go fast. Trying to find you another one. Anyone have similarities? What do they both end with? What are 9 and 121 both called? Perfect squares. They both end with perfect squares. What do you notice about your sets? Come on, help me out, man. Someone besides that. Or Annalise, go ahead. Someone else. They have the same signs. Okay? Both end with positives. All right. I'm not going to give you guys the pattern. You're going to have to figure it out. Number 4 or number 10. We're not done with either of those. Well, we are, I guess, with number 5. Didn't have to divide by A there. But number 10. Go ahead, ABC. Okay, 4, negative 20, and 25. Does anyone want to take a guess right now what's going to be in here? We know it's minus, minus. Anyone want to take a guess what's right here? Yeah. 10? Why do you say 10? Okay. Anyone else want to take a guess? Yeah? Square root of what? 100? Okay. So you're saying 10 as well? Yeah. Okay. So you did 4 times 25 to get 100. Okay. We're saying 10 and 10. Everyone agree? It's 10 and 10. That adds 20. Okay. It's the same number again. We keep using the same thing, right? We keep getting a perfect square. Notice we get that perfect square because we end with a perfect square. Did we begin with a perfect square? Is 4 a perfect square? Yeah? How about up here? Is 4 a perfect square? 9 a perfect square? How about here? Is 121 perfect? Is this number perfect? What is it? It's 1, right? Perfect. Okay. Well, let's finish this problem out real quick. What do we divide by? 4. When I divide by 4, this reduces. What goes into 10 and 4? 2. How many times? 5 and 2. We're going to make this even easier. This pulls out in front. We get 2x minus 5 and 2x minus 5. Anyone see how to get from this to this? Look at your patterns again. All right, hold on. Let's go back to this one. Number 5 and number 4. We already have this one. This is 1x minus 11 and 1x minus 11. This is 1x plus 6 and 1x plus 6. However, we have to divide by 4 here, right? So when I divide by 4, what happens? What's this become? Okay, 3, and this becomes 2. So we got to bring those 2's out in front. That becomes 2x plus 3 and 2x plus 3. Anyone see how to get from here to here really fast?
I do.
How many think you have it? Okay, if you think you have the pattern, skip down to number 9. Let's see if you can apply that pattern. You should be able to look at that problem and go, oh, dude, perfect square. Perfect square. Positive. Woohoo! That means I have the same sign, which in this case minus minus. That's x, and that's x. You guys fill in the blanks. All right. Show your neighbor. If you know how to do it, you'll have it already. Okay, who has an answer on their paper? Just so I know where we're at. Okay, anyone want to volunteer it? Go ahead, Bobby.
3x minus 5 and 3x minus 5.
Okay, good. The square root of 9 is 3. Square root of 25 is 5. 3x minus 5, 3x minus 5. Now, how many put that? That is correctamundo, dude. These are the perfect problems. Why are they perfect? Because they begin with perfect squares and end with perfect square. Every problem we are doing today, with the exception, I guess, of these where we have to take something out first. But if you can get your quadratic to begin with a perfect square and end with a perfect square, you're loving life. Like here, you should be looking and praying as you're going through these problems. You're like, dude, please begin with a perfect square. Yes. Please end with a perfect square. Yeah, dude. Is it plus? All right, man. That's awesome. Now, if it was minus, would it work? Doesn't work. So on the trinomials, you have to have a plus in the back. In the binomials, you have to have a minus. So make a note of that. You like the patterns. They save you time. Okay? But you need to know how to use them. You should be able to look at this one and go, hey, that's x plus 12, x minus 12, x minus 12, because the negative b. All right. Questions? All right. Give yourself a couple minutes, work on those other trinomials there.